working here at the Maryland School for the Blind. So I know the sign up was called Pathologies, but for many people who are new to this field, I didn't want to necessarily go too in deep to like diagnoses and the mechanisms behind them, but I rather wanted to give an overview of the visual system and then outline different areas of functional vision that can be impacted by a visual condition so that you'll walk away just with a different way of thinking about vision, because I feel sometimes people fall into this black-white thinking of like, you're either blind or you have all your vision, but there's many people that they live somewhere in the middle, and today's going to describe a little bit what in the middle can mean. Okay, so our learning objectives for today are: we will describe the effects of a simulator on participation in visual tasks, acquire knowledge of basic functions of the visual system, and recognize common eye conditions seen at the Maryland School for the Blind. So the first thing we're going to do today, we're going to jump right into an activity, or several activities that will require your participation. And so I have 5 activities planned. I'll ask for 6 to 8 volunteers. We have enough simulators to have more, so it depends on your participation. We'll come up and I'll give you a visual task to do with the simulator on to give you a little different understanding of how a visual condition can impact what someone sees. But a note about using a visual impairment simulation. So the National Federation for the Blind, one of the largest advocacy organizations, has a great paper published called The Perils of Playing Blind, Problems with Blindness Simulation and a Better Way to Teach About Blindness. And some important concepts they highlight about using simulation is that simulation does not fully represent the experience of living with low vision or blindness. When a sighted person puts on a simulator, it often parallels the experience of first becoming blind rather than having lived many years with a visual condition or blindness, or for a child who what they see is all that they know. And simulation is always meant to develop knowledge, understanding, empathy, but sometimes it can result in the person who participated maybe feeling more frustrated, or maybe they think someone with a visual impairment is incompetent because of their sensory loss. And it could inspire someone to have low expectations of someone who has a visual impairment. And this is not what we want you to take away from this. We just want to break down functional vision into different areas of function and help you understand what that's like. And a more complete experience would also include training in blindness skills, low vision technology, adaptation, and we'll speak to some of those as we go through the visual system and functional vision, but unfortunately we only have like an hour and a half today. And if this is something in your department you'd be interested in, exploring more, especially in regards to some of the students you have, we're always happy to come out and help you think about that, contemplate that, and learn more. Okay, so for our activity today, we're going to have 2 roles. So I'm going to have my volunteers, and I think in this audience we'll have a lot of them, right? Everybody's going to want to volunteer. And we're going to call you the doers. You're the people who are going to don simulators. You're going to be in front of the group, and you're going to participate in an activity with some instruction. And then everybody else out there, you're going to be our observers. I want you to watch participation, see if the person's trying to compensate in any way, and just take some brief mental notes about, what was it about that activity that, maybe was different for someone sighted versus wearing a simulator. All right, so, we ready? Okay, so, if you feel so strongly to be one of the first volunteers, I'll have you stand up. Oh, Sally, thank you. And you too. Oh, we need 6 to 8. So, Sally, yeah, come on up. Anthony, I have some good old friends up here. Okay, yeah, you can stay there. All right. And maybe I'll give you a pair of these. Sally, you're wearing glasses.
I'm going to take them off.
You can take them off. I'll give you those. Those fit over sometimes.
I just took my glasses
Anthony,
off.
I'll give you these.
I need like 3. That didn't work. 5 more. Come on. Everybody gets a turn.
Yeah, so we're going to do 5 activities. I'm going to need a lot of volunteers. So you can be one of our first people, or if you want to wait, that's fine. Okay. We can start with this, and once you guys see...
I got one more coming.
Oh, great. Perfect. Once we see how much fun people are having, they're going to want to come in.
Amanda, do you have a preference on what we're doing?
Let's see. Hello.
Maybe...
Two down here and one there.
Okay. Did you put yours on, Anthony?
These are these considered.
Yours aren't on. Put those on, Anthony.
That's okay. All right, so I'll give you... Oh, and then...
Which one do you want?
maybe we'll do these. All right, I'll give you these. All right, you can get those.
Okay, so
Paper out of the way. Okay, so... Yeah, can you step over? Yeah, Anthony, step to your right. So we're working on directionality with Anthony. Okay, so for our first group, I just did a load of laundry, all clean laundry, I promise, and I need you to sort the laundry as a group by size and put it into categories or piles for me, okay? So you just gotta work together. I'm gonna bring some clothing down the line. Okay.
Sorting it?
So sorting it by size.
Size and type.
By
I'm
size.
moving my glasses back here, guys. Just putting them. Okay, what are we
Oh, Miss Sarah added also by type.
Oh yeah, sorry, size.
Okay, just sort by size.
All right, look.
And talk, you guys can,
You have a shirt?
This is like an extra large. I don't know if it's extra large too. Or an extra large adult. So actually, they're gonna go to the right. Extra large.
Size and type. How do we do size? Anything you want to tell the rest of your group? Oh, this is jeans. I don't know. Anybody have jeans? Good pants?
Yes.
Here's pants.
Oh, I see. Okay.
He ain't that small, but he like a medium sized kid. Yeah, medium sized.
These are big pants.
Big pants.
These are large.
Anthony, he wasn't looking at the tag, but he was judging by how big the garment of clothing was in his hand.
Large shirt. Large shirt. Uh-oh, what's this? I think I underpants.
And Sally, again, she's judging by how big the clothing feels in her hand.
Anybody else have undies? Undies, little tiny ones. Girls, they're little. Okay, 2 little ones.
Like this is like that's like a small shirt. This is a small shirt. Small shirt.
Oh, these are big undies.
This is a small shirt. Y'all got some small? Yes. Here go small shirt.
Anybody undies down there?
Undies?
Here's the big ones.
Okay, that's big.
Big ones.
Okay, little ones. I have small boy undies. Anything
All
else?
right, and do you guys think, is this your final answer? Okay. Well, you can go ahead, you can take the simulators off and put them in front of you. I'm gonna give you some little alcohol wipes to wipe like the nose pieces and around where it touch your face. But just based on, a couple minutes, do any of you want to share what seemed different about your vision when you're under the simulator?
Very, very difficult. I mean, I could see just very minimal. With these, I could see very minimal light. Nothing complete in front of me, so I was just seeing light on around the perimeter. I mean, I could see the really bright, this one, but other than that, they all looked the same. You could just feel the different texture.
Sure.
Yeah.
Okay.
Which simulator did you have?
What is this? Number 2, I don't know what that
Well, so this one I think is like a cataract. Yeah. And we'll talk in our presentation about kind of the categories of these, but I want to hear Anthony, I know you have something to say. Do you need a microphone?
No, I'm good. How y'all doing? Like, for me, this is more so like low vision. I still could actually see. But for me, it was something they probably said don't do. I would like close one of my other eyes to try to compensate to get more clarity. I noticed like when I close one of my other eyes, I got to better see like, oh, these boy underwear.
Do you wear glasses?
Yeah, I do have glasses.
Are they just readers or are they?
No, they both. They're progressive.
Okay.
I got progressive.
I'm just interested.
Okay, yeah. Okay, yeah. So,
You have something to add. What's your name?
Morgan, okay.
I could pretty much see it was giving off like bifocal feel, but it was clearer when I put the clothes closer. And then when I moved,
To see what when you brought it closer?
oh, the size.
Oh, that's right.
Because it's really small, so I can see it when I brought the clothing closer. And when I moved to grab a shirt, I know the shirt was right here, but I kind of like grabbed over here. And it was a little like woozy, and I was like, oh, okay. And I was like a 2 or a 1, so I don't know what vision this is.
Yes. You don't have to, but. That's okay. Oh, yeah, you guys were similar.
Do you have anything to add about your one side?
No, I guess I can't see very good
Yeah. And so I'll just say this now. I have a slide after the activities, but one thing we have to consider with these, like if I take my glasses off and put simulators on, now I have my uncorrected vision, and then I'm adding another layer of something else going on, and we'll talk about that a little more, but very good. What is in the middle of your simulator? Yeah, so there's a spot in the middle of her one lens, and so something in the middle. So these are just kind of things to keep in mind as people are sharing their experience. All right, thank you all. You're free to do it. You can just put it on that table up there. I'm not putting it up there. Okay. Yeah. So now I need 6 more people. 6, 8. Come on out, outreach. You guys are my friends. Come on. And we have lots of lovely people in this room. Emery, Cynthia. All right.
Our department's going to be very over.
Amanda, ask the observers if they noticed anything they want to come and say.
Are there any observers who want to comment on the first activity? You guys are saving it, right? Okay. I expect some really well-formed ideas later on. Okay. Yeah. So you guys can go ahead. We have enough for this one. I'll use the next one. You can go ahead and put your simulators on.
As you're to take your
I know what we'll do. So that's a charge. Okay, so this next activity we're doing, it's called the sprinkle chase. So we have 2 teams. It's going to be divided between Emery and I'm looking at and Melody. And so each team, so I don't want anyone to know that I'm celebrating Halloween too early, but I over-poured Halloween sprinkles into these 2 dishes. And I need your help to try and pick them up and put them in, there's a nice little trash receptacle by you. So I would like each team member to pick up at least 10 before they pass it on to their teammate, and we're gonna see which team finishes first with helping me clean up these sprinkles.
You mean one by one?
Like, yes, individual.
Yeah, individual sprinkles.
Individual sprinkles.
You know what I'm asking you to do.
Like any 10 sprinkles?
Yeah, any 10 sprinkles, yep. So, on the count of 3, so we're starting with Emery and Melody, are our first ones. You're gonna pick up your 10, put it in your aluminum tray to help me clean up, and then you're gonna pass it for Melody to your right and for Emery to your left, okay? And then we're gonna end with Tanya and Erica. Sorry, Erica, sorry, okay. You are. Okay. Okay.
There's more than one of us, though.
I can go one other. All right, so I'm going to count down. 3, 2, 1, go! I see what Miss Brittany did.
Oh, 2 snaps for Miss Brittany.
I think Erica sealed the deal. We're going to give Tanya the experience, and if she doesn't feel like she got enough, she can stay up here for our next one too. Because I can pick on her. All right.
Go ahead.
You can take your simulators off. We'll pass out some alcohol wipes. So, any initial reactions to, oh, thank you. Yeah. They're really great sprinkle chasers. Any initial reactions to how your vision was different with the particular simulator you were wearing? Emery?
Yeah, I couldn't see color basically at all, so I was very confused about why you said these were Halloween sprinkles until I took them off. I'm like, oh, okay.
So your particular simulator kind of obscured differences in color. All right, any other? Oh, Tanya.
So I could see straight ahead, but I couldn't kind of see peripheral, and I definitely couldn't see down. So I kind of had to move my head around to compensate for it.
Very good observation. Yeah, Tanya's simulator has, again, a big dot in front of the middle of each eye.
Sure. I mean, I just had
Okay, you're good.
I just had just poor vision all around, so I just used my ears to listen.
Just really blurry.
Yeah.
And then, if people don't know Miss Brittany, she's a teacher of the visually impaired, and she just used a different sensory modality to complete the task.
So, do you want me to do it?
No, it's fine.
Same thing I did.
Okay, so that's what Miss Erica did
This
too.
one, total blackout on one side, and then very cloudy and a total blackout
In the center.
So,
Yeah. It was,
Yeah.
They're just like, turn this off. I'm just going to use my sense of touch. Just like I teach my students to do. All right. Oh, and Cynthia.
So mine was kind of like the same thing. I could only see straight ahead, and so I had to turn my whole head to do anything. So I have a little personal experience with that, with the muscles and the eye not being able to move. So using both my hands, so I didn't have to keep turning as much to kind of compensate for that, so I could get it done faster.
Very good. Next time I do this, I'll make it. You can only use one hand.
Yes.
All right. Thank you all. All right. Keep on coming. I don't think I had anyone from nutrition staff up here. What about the health center? I see Miss Lenny standing up. Mr. John. All right. They're coming up. Yeah, that's okay. All right. Yay, we got some friends. Come on up. You can line up wherever. And these simulators, they don't have to stay at any particular station.
Yeah, you can switch them around.
Yeah, you
Grab
can
the
switch
one
them
you
around
want. Grab
based
the one you
on
want.
what's interesting.
Grab the simulator you want. Doesn't matter. Yep. I'll take
And
a
then
try.
this one here. So you may have to take them home. And then to the point, this direction, put the strap over your head, okay? All right. Go ahead. Go ahead and just get used to those for a minute.
One on each.
Yeah.
Maybe the ends.
Let me make sure everybody is good to go. All right. So, as I just told you, I want to believe that it's time for Halloween, but it's still summer. And so our next task is called Pour Me a Drink. I need to stay hydrated, and it's Friday. And so on each end, there's a pitcher and a stack of cups. And I want each person to pour me a glass of water so I can stay hydrated because it is still summer. Okay, so whenever you're ready, whoever's on the end can go ahead and just, pour me a glass of water, and when you're done, you can pass it to the person next to you. All right, then you can put your, sure, I'll come take it from you. Sarah, where's this water from? It's from a kitchen. Okay. Oh, I see Mr. John is also compensating. He's learned some strategies.
Everybody got water? My neighbor got water?
All right, so our first observation is that Chrissy had no clue her partner had already finished pouring his pitcher of water and was sitting here waiting for her to pour because no one gave her a cue that the pitcher was there waiting, and she had no clue it had been sitting there for 5 minutes.
We don't exaggerate ever when we're teaching, right? Okay. I didn't even realize, we started 12 opposite ends of the table. I'm so busy. Go ahead and take your simulators off. We'll pass out some little wipes for you to wipe around, like the nose piece and wherever it touches your face. Okay. So, any initial observations?
Actually, it could see pretty good through here, which is scary.
So someone said, I've never seen better than Any other Miss Chrissy, Miss Lenny, any observations of how you did the task? What?
For me, it was very blurry. I couldn't see. It was just so blurry. If I bend down, I could see it, but I had to get close to it.
Yeah.
But then it just made me like, I leaned on Dawn, like, listening to her, what she was going, like, did you pass the water?
Has anyone ever noticed a student maybe, depending on their classmate, to cue them into, what am I supposed to be doing? Any other contributions to the discussion from this group?
I think an experience we were talking about before where it was just like I was so disoriented that it was like just hard to.
And I think particularly those are a really strong like prism lens, and you have to bring anything really close to your face to focus. Yeah.
I felt very dizzy just wearing those. But I think with the water, it is something I already know how to do. I can't imagine learning how to do that.
Yeah. And the reason, in case you couldn't see in the back, we gave very tiny cups because it's very easy to overpour. Yeah. And if you're visually monitoring how much you see in the cup, it's a little easier to overpour if you take away a little of that visual sense. Yeah, and Miss Chrissy, Mr. John, they used a blindness strategy called the finger method to help use their sense of touch for pouring rather than their vision. Very good. Thank you all. I think that's the messiest of activities I have. All right. I have 2 more, and I think our next one is my favorite activity. So, Mr. Tim, Mr. Drew, you two would be prime candidates to do this. Yeah, I got 2. Who else do I have? There's a lot of people who I don't recognize. Maybe you're new here this year. I would love to learn your name. Good, we have someone else coming up. I'll take, so I have 4. Oh, is Marina coming up? Or yes, Marina's coming. I'm going to get you all chairs for this one. Chair. So when you get up here, you can go ahead, grab a chair, sit down, put your simulators on.
Here. pass this one through. Oh, here, Sarah, I can give them this one.
Mr. Tim will do it.
Yep.
If you need something done, he'll take it. Alright.
They used all my paper towels, they spilled.
Yeah, that, I probably should have ordered these a little different, but that's okay.
Is it okay if I use underwear?
Yeah.
We ran out of paper towels.
Alright. So, I'm gonna come around and pass y'all a piece of paper each. Whew.
Yeah, I was just saying, it's wet on the table, so you may want to do it. 3. I need one more. Who would like to come up?
All right.
Yay.
Okay, and then we're gonna pass out some writing utensils. That one. Mr. Drew,
Yeah.
what can I do? I'll give you this one. I'll give you that one. Okay, so this next activity is called, how are you feeling about Strand training? All right, let's check in.
Where are they?
Let me find, oh, I have them in my hand where I did. I just have them. 1 second.
They're right. Okay.
Okay. So, I have 5 photos of people's faces. And what I'm going to do is walk down the line and give you a chance to take a look at their facial expression. And I want you to write on the piece of paper, how is this person feeling? All right, so I'll walk down your line first and then I'll show our audience. You ready? Okay, so I'll start with Mr. Tim. This is Sadie. Sadie will say she works in the health center, all right? How is Sadie feeling about Strand training? And just go ahead, write it down on the paper when you're ready. Mr. Drew, how is Sadie feeling? Okay. I didn't catch your name. What is it? Joshua. How is Sadie feeling? All right. So Marina. All right. How is Sadie feeling? All right. So, if anyone, how is Sadie feeling? I know some of you in the back. Oh, that's how you feel too, Eric. Okay. So we're getting some audience reaction. And here's Sadie's facial expression. Okay. All right, Mr. Tim, you ready for
Phil. Make sure you write
All right.
Sadie. The next one's Phil.
Here's Phil. There's Phil, Mr. Drew. Let me know when you've labeled that feeling. Okay. All right. How's Phil feeling? All right. And then for the audience, this is how Phil feels about Strand training today. It's. All right, so this is Phil. This is how Phil's feeling today. Okay, next we have, this is Jim. Did you already see Jim? Yeah. Oh, now Mr. Drew is just making stuff up. That's how he copes with his change. All right. This is Jim. All right. This is Jim. Miss Erica's helping Jim label his feelings, reflecting that. Okay. This is how Jim's feeling. Okay. I'm just going to leave this with you. Okay, next we have Bill. Bill. Mr. Bill. Mr. Bill. Mr. Bill. Alright. And then we have one more which you may have glanced at, so I'll be covering it. Okay. Now let's fast forward. This is Monday. Sadie came back to work. She she's feeling a little under the weather. You asked her how Strand training was, and this is her expression. So Sadie came back Monday, feeling a little under the weather. You asked her, she changed her mind about Strand training, and this is what she looked like. This was her facial expression. So Sadie, who came back to work on Monday, maybe changed her mind, maybe she didn't. But you asked her about Strand training, and this is her facial expression when you guys talked about it again. You know, maybe she had a change of heart, maybe she didn't. All right. Okay. So y'all, that's all for our facial expressions. Go ahead, take your simulator off, and I'll have you, if you would like, please do, share, you know, what was the impact of the simulator on reading someone's facial expression? You want to think about that?
I just could not see any expression. It all blended in together. I could see outlines fine. Like I could see like the outline of the paper, the outline of the pencil, but anything with a bit of shadow was just gone.
Couldn't differentiate,
Yeah.
couldn't distinguish. Yeah.
Marina, of course, thank you.
I felt like I could see if the expression was really dramatic, like if they were angry, like if their brows were furrowed or something. But other than that, everyone else kind of looked neutral.
I love. She was given a yellow highlighter to write with on top of the expression. So we see this sometimes, given a yellow highlighter, a yellow marker. So I can't even read back what some of this is. Bill, maybe that's Bill tired. I got it. Okay.
It was doable, but I had to move my neck around a lot so I get to the right spots. Yeah.
Mr. Drew, Mr. Tim?
Go ahead, you first.
Okay, I go first.
Okay.
Mr. Drew.
Mine was, I could see facial expressions with the television, but I couldn't see, I had to look at different parts, so I had to look up to see the eyebrows, look down to see the frown on some of them, so just kind of, again, moving my head around, kind of seeing the different parts instead of seeing the whole picture.
Same thing. He was given a yellow highlighter to write with, and his is not straight lines.
Anything else to add, Mr. Tim?
I had to look a little closer because it was blurry, but to be honest, I might have to look into myself because I said everyone looked kind of angry or sad.
He did for every single one.
Except for the last one, it was a puzzle.
Yeah. You know, I did. Oh, okay.
For Bill was a puzzle, but
Totally.
I had to look a little closer, but it was kind of hard to tell because of the blurriness.
The very last, so there's blurriness, you have to look around, hard to tell, hard to distinguish. The very last one, Sadie, technically online, was labeled as happy. So just in case you're feeling a little bothered by today, on Monday, you could feel different. Okay. So I think I have to move on because I realize we only have 20 minutes left. So thank you all for your participation. I'm going to cruise through some slides to try and get into this conversation of functional vision. And they brought up a lot of great points that I'll bring you to our other slides. So I think it will let me go. Can you click next on there and see if that works? Oh, or just does.
Yeah, if I don't leave.
If you, let's go. Oh, you know what? I was wrong. I can't tell time. I still have another hour, so we're good.
You do the last one?
I was thinking.
Yeah.
Oh, should we do the last one? Okay. Yeah, we will. Why not? All right. So let's get maybe 5 people. Can I even get 5 people to come up here? I haven't seen Hey, Sharon, Kate, yay! Thank you, Sam. Oh. Yeah, and you'll just stand in front of the table.
And let me, oh, I was cleaning those, sorry. This one.
Oh, we have some repeat offenders, but that's okay. They are really increasing their knowledge today. Okay. Let's see, these are good for someone without glasses. These are okay. All right.
Do you need any more?
I think we need just one more.
Which one do you want?
Let me take these.
Here, I'm gonna get the rest of these.
Okay. All right. Okay. So, I actually should have spread you out first, but I'm going to have you take my elbow and I'm going to put a little space between you all. So, just so that I can, and we're going to walk to our left, please. I'm just going to spread you out for this activity a little bit. If you feel comfortable walking, I'm just going to put everybody in a little spread out of a line. Okay, so there's you, and then Miss Patty, you can step to your left a few. We have to be careful when you're wearing them, just to make sure it's good balls. Okay, and then Melody, I'm going to have you step to your right a little bit. Towards me one more. Okay, very good. So, our next activity is called Strand training. It's all fun and games. And the goal of this activity is we have a soccer ball, and Miss Sarah's going to be on one end, I'm going to be on the other end, and the goal of this game is going to be to just lightly pass it to the person next to you. I'll have Sarah start on this end, and once it makes it to me at the very end, then we accomplish the task.
Amanda, small or little first?
We can do the big one, yeah.
All right, feet only, please. Oh. Here we go. Oh, it's coming to me. Yep.
And yeah, you can move to it. Miss Patty's gone. All right, and then if you could just, if you want to go the other way, you can skip me. I don't got to do this. Oh, go ahead. Oh, that's a good pass. All right, and now Miss Sarah has another one coming. All right. Yeah, you did good. All right. You can go ahead, you can take your simulator off and just put on the table behind you. And put your glasses back on if you got those with me.
Nice work.
All right. Any initial observations of how the simulator made a difference in your participation? All right, Melody, you're champion today.
I could not get the image and like the whole frame. It was like very small, so I had to keep turning my head, and like in the middle it was like black. So it was like a very small vision of half of what I could see, and then it was black, and then I had to like turn again to try to complete the image.
I could see that it was something in front of me. Everything was just blurry, but because the edges didn't have sharp edges, it made me more cautious to make sure I had my actual object.
Yeah, and it is blurry, especially looking around. You see all the people that are here today, and you look out there and you try to see, who's who, and it's blurry. But then playing this game was pretty interesting, as far as feeling or whatever, using your feet and then trying to pass it on.
I was the kind of same way. I had some vision like in the middle, but not very much, so I was moving all around. move the ball.
Yeah, yeah.
So to keep that ball in your visual field, you're having to move around a little bit to keep it there. All right. Thank you all. Can we give some round of applause? Thank you. And now that I know, we got an hour. We'll marinate on some of this information for a little bit. Okay. Let me get reorganized.
Anybody from the audience want to share anything they observed about any of the activities? Anybody from the audience want to share anything they saw, observed from the activities? Yes.
So the last activity, I'm sorry, the woman on the end.
That was Melody. Yeah.
She had to hold on to the table when she moved her head.
Yes.
So as she was trying to plan her movement, keep herself upright, she looked for physical support. Any other observations during any of the activities? Yeah, Joshua.
I noticed, I did watching, it was definitely a pause or delay between like thinking of an action, how you approached it, and doing it.
Right.
So,
Yeah, that's it.
That's a good observation. And like that article from the NFB, simulation is more going to mimic someone who's newly acquired vision loss, where, you know, an adult with vision loss may kind of experience a time when they're very cautious as they're learning, you know, what can I see? How do I compensate for it? So it sounds like you were using a lot of mental effort in order to participate, or for the other people to participate. They were pausing before they moved. Any other observations? Sure.
Yeah, from working with, at the MSB, and then working with somebody that has a vision problem or like that, and then to hear them say, I need your eyes, or you know, and they got, of course, they got to feel things if something's not clean or whatever, whatever, to find out to make things better.
Yeah, and what we didn't get to go over today with these activities was how does someone compensate for vision loss? And, you know, can you use your sense of touch? Can you modify the materials you're using, the environment to help with visibility? And so that's a really good point is, you know, today we're talking about conditions that cause differences, but there are a lot of ways to kind of bridge the gap so that someone can participate efficiently and effectively. Any last thoughts? One more.
Yeah, I was going to say, as far as with like, I was told that if you see wavy lines out on the road when you're driving, then you know you got a problem, then you know you got to get help.
Yeah.
For degeneration.
Yeah, and that is a condition that you will see on a couple of our slides. And he was talking about macular degeneration, so that's a condition where one of the symptoms can be that, you know, something that you would expect to be a straight line, like maybe the double line separating two lanes of traffic, it would kind of look wavy, or for some people maybe even moving a little bit because of what's going on with their eye condition on their retina. Thank you for all those contributions. Let's see if this clicker is working. Let me go. I was supposed to click through these, but I did not. Okay, so just, we did our discussion, and something to mention about the simulators is when you put them on, they may not line up perfectly with where your eyes are, where your pupils are, where your gaze is, and so there are some ways to kind of cheat around them. And so again, simulation, it's not going to give you the full experience or picture of what that looks like when someone has a condition. And also, if you couldn't wear your glasses with the simulator, then for me, it would be blurry and then maybe something else going on top of it. And so just to keep in mind with your experience or your observations that when someone has a blind spot or a change in their vision, it generally moves with their eyes. You can't move it out of the way. All right. So now that we have some experiences to contribute to discussion, we're going to go over the visual system, and then we'll go into conditions that impact the visual system. And for today's discussion, we're going to simplify the visual system into three parts. You have your eye, which is what people think of when they think of seeing, but our eye is often compared to a camera. It's what takes the picture, it's what detects light. And then you have the optic nerve that sends the message from the eye back to the brain. And then the brain is where all that information about light gets processed in different centers. And we're going to break down each of those just a little bit and go over some basics. And actually, I have a model of an eye. It's got some tape on it, be gentle, but feel free to pass it around, take it apart throughout the rest of the presentation so you can look at the parts. All right, so the eye, that's our sensor. So that is what is detecting there is light out there. And we're going to start with the back of the eye. So in this image on the screen, there's the eye. It's kind of cut open on the top so you can see inside. And we're not going to talk about all the structures, just some main ones, some key ones. So this image, the red, that is showing you the tissue at the back of the eye called the retina. And that's where those cells called photoreceptors are located. And those get excited when light hits them. And now we're going to go back to the front of the eye to continue the discussion. So you have a couple clear structures that light passes through. On the very front of the eye is the structure called the cornea, and it is a rounded shape. And so as light comes into the eye, the light is actually, it's bent by this structure that's called refraction in order to try and target the light on the retina at the back of the eye. So once the light passes through the cornea, the next structure that is important to know is the iris. And so the iris is the color part of your eye, and it actually contracts and expands and controls the size of your pupil. And that controls how much light is being let into your eye at a given time. So in a low lighting situation, your pupil is going to get bigger to try and take in more light to get back to the retina. And when there's bright lighting conditions, your pupil is going to get smaller to try and let less light in. And after the light passes through the pupil, the center of the iris, you're getting to the lens, which is like this little hard structure that actually changes thickness depending on what you're looking at and where you're looking in order to direct and bend the light to, again, hit the back of the retina where those light-sensitive cells are. And then we go back to the retina, which I explained in the beginning. So these systems, and there's more to it than what I'm going to go over today, but they're working together to really try and get the light back to the retina. And in the retinal layer, there's two types of cells. There's rod cells and cone cells, if you've ever heard of this. And there's many more rod cells than cone cells. Those rod cells are the ones that specialize in detecting light in lower lighting conditions. So they're really important, at dawn and dusk, and they help sense, shadow and shades of colors. And then the cone cells are really concentrated at one point in the retina, or one area in the retina called the macula. And when the light hits that area of the eye and all those cone cells are stimulated, that's giving us all of that sensory information about color and detail. And those need a lot of light to be activated. And something I find interesting when we think about the anatomy and structures of the eye is different species have different kind of compositions of the eye. So for example, another species that many of us know very well are dogs actually have a lot less cone cells and a higher proportion of rod cells. So for like my dog Trixie, she doesn't see in nearly as much clearness or color as I see, but in lower lighting conditions, she's better able to respond and see better and detect like movement and shadows. And that goes back to, if you think about evolution and, what different species have to do to survive. She probably, or a dog, a wolf, would have to really detect movement in order to react, in order to chase prey. And in thinking about the entire visual system from the eye to the brain, so the message going back to the brain is really dependent on these structures being intact, getting that really clear image before it even gets sent back to the brain to be processed. Okay, and then here's just another image that is showing the light rays and passing through first the pupil, well, the cornea, the pupil, the lens, and hitting the back of the eye. And then it's showing in greater detail, there's actually 3 types of cone cells, red, green, and blue, and then the rod cells are in gray. And so the light's hitting them and is kind of stimulating them in order to cause an electrical signal in order to travel down the optic nerve. So the optic nerve is the next kind of piece of that puzzle, and so that electrical message from those photoreceptors travels down the optic nerve, and we can see that the image on the left, you see from the side, the eyeball, the optic nerve as it goes back to the brain. And the image on the right is an overhead view of the brain, and it's showing how both eyes actually are getting different sensory information, 2 optic nerves, and they actually come together and cross before sending information back to the brain. And some more images. So there's the eyeball with some layers taken away, so you can see how those fibers from the nerve cells are traveling. And then here's an image of an anatomical eye. What does it look like? And the optic nerve, when I looked this up, it's about 1.5 millimeters kind of wide, so not real big, but that's actually bigger than I thought it would be. Okay, and so then we get to the brain, and I am not a neuroscientist. I find it very interesting. There's a ton of research about vision in the brain. We're very lucky that in the months of November, December, we have 2 experts coming in to talk about visual impairment as it relates to differences in the brain. But for today's discussion, we'll talk just a little bit about the main centers of the brain and how they relate to vision. Is anyone familiar with any of the frontal, parietal, occipital, or temporal lobe and want to give kind of their brief understanding of what the specialty is for each of those areas? Do we have any armchair neuroscientists here? Oh, Cynthia.
Isn't like the frontal lobe like the thought process, and the occipital is behavior, and then I don't know the other one, but and cerebral, yeah. I think the frontal is like thinking, and occipital is behavior, right?
You scored a 50%, but that's okay. So the frontal lobe is like personality, executive function. It plays a big role in that. Decision making, executing movement. And the occipital lobe, do we have anyone who wants to give a guess or tell their knowledge of what the occipital lobe is? Oh, I have a hand.
How about ego and super ego?
That's getting a little into psychoanalytics for me. Okay, I have someone, Anne-Marie.
Vision. It's responsible for our vision.
So the occipital lobe, which is a pretty fancy word, right? But that is where that raw information about color, clearness goes to be processed. And I'll just say this parietal lobe, that gives us our sense of where things are in space, and that's actually our specialized part of the brain for processing all sensory information. So touch, taste, smell, hearing, and so all of that gets integrated in the parietal lobe. And then the temporal lobe is where specialized for memory, speech, recognition. So all of these centers, and then the cerebellum, I didn't mention that one, that one's on the bottom, is really involved with like coordinated movement in our balance center. But if we talk about vision, so the image goes through the structures of the eyes, the information travels down that optic nerve. So there's a blue line going from the eyes, optic nerve, traveling back to the occipital lobe. And then that information gets sent to the parietal lobe, and that's going to tell us about where something is in space. So in the vision world, we call this the where pathway. And then the temporal lobe, there's a pathway in that direction, we call that the what pathway. So what is it I'm even looking at? You know, we have this file in our brain that remembers that something's a pen versus a pencil. And then the frontal lobe helps prepare a response to visual information. And once you go deeper from those centers around your cortex, and I am not going to talk about any of these because that is a lot. There are all these other specialized centers a little deeper in the brain that help our gaze shift and filter out extraneous information in the environment. So there's all these conscious and subconscious processes that tell our vision where to look. And then this last slide was from a study. I did not really read it. I read the abstract, but I thought it was a good image. So this next slide shows an MRI study that looked at using visual information. It had 9 subjects, so these are 9 different brains, and then how the brain responded to visual information. And you can see there are differences, but it also just shows there is so much connectivity between the different centers of the brain, millions of pathways that in an instant you see something and all this activity happens. And all this is to say, if a child or an adult has a difference in their brain, any of these areas could impact the use of vision. Okay, so I'm going to go back to this slide for a sec. But, so now we talked about the eye, the nerve, the brain, and any of our kiddos at school, they could have a condition that impacts one, they could have another condition that impacts another part of the brain. So it's important if you're looking at a student's file and trying to understand what they see, it could be they may have a condition where they're not getting a clear image to begin with. Maybe there's a problem with the message being transmitted, or there could be a problem with how they're interpreting that message, or how they're even able to pay attention to visual information. So now we're going to get into more conditions and blindness and low vision. And to start just at one end, before we talk about low vision, blindness or near blindness is kind of the one extreme, and it's actually very rare for someone to be completely blind, see no light. It's more common for someone who identifies as blind that they still see maybe some light and shadows, maybe even some form perception. And so I organize these conditions that are commonly seen at MSB based on where they impact the visual system. And so you may see some students in programming who have a condition affecting the retina, so the light sensing layer of the eyes. A common one is Leber's congenital amaurosis. Another condition we see a lot at MSB is retinopathy of prematurity. And for anyone who hasn't heard of this condition, so when babies are born extremely premature, often different kind of parts of their body didn't get a chance to fully develop. And for retinopathy of prematurity, the eyes are impacted in their development, and then this process is developed where abnormal blood vessels are developing in the tissue behind the retina, and it can cause the retina to detach. So that's the condition under it, which would cause a vision loss. There's also students who may have mild ROP from being born premature, and kids with, or babies with mild ROP, it's likely that they don't need any treatment and they can still develop typical vision. And then it's also common that a child may have one eye that has more severe ROP than the other. And so just things to keep in mind if you see this diagnosis on a student's file. Other conditions that may cause blindness or near blindness are if the child has an abnormal shape of the eye or the absence of an eye. And so microphthalmia is micro, so small eye, and anophthalmia is the absence of an eye, and this usually is attributed to genetic conditions. Enucleation is the surgery for removing an eye, so that could be another reason why a child doesn't even perceive light is because they've had to have the eye removed. This could be due to an infection that maybe puts the kiddo at risk for other issues. It could be due to cancer. And I wouldn't say it's uncommon at NSB that there's a kid who wears like prosthetic eyes. And so that's to keep in mind that if the eye isn't there, there's no light being transmitted back to the brain. Conditions of the optic nerve include optic nerve hypoplasia and septo-optic dysplasia. So septo-optic dysplasia has other features associated with it, but one of them is optic nerve hypoplasia. That's a feature. And then glaucoma is increased pressure in the eye that causes damage to the optic nerve and vision loss. And then it can cause someone to lose most, if not all, of their vision. And then a brain injury could cause someone to not be able to sense light, depending where the injury was. Okay. So now we're going to move along the continuum to low vision. And this is where I'm going to need y'all's participation as we talk about different visual functions and your experiences and observations of the simulation. So low vision is a condition that cannot be corrected by medical or surgical intervention or by eyeglasses. It allows some usable vision, but is severe enough to interfere in completing daily activities. That's from the National Eye Institute. Previously, people would hear the term partially sighted, but there's been a movement towards using the term low vision. I had a student once say to me when we were talking about low vision, she said, "But my vision's not the lowest, right?" And it's not really a measurement, it's just a category to describe someone has a visual condition that, glasses can't correct it. So in our discussion of low vision, we're going to talk about different components of functional vision that impact the clarity of that message. And so today we were able to simulate differences in visual acuity, visual fields, and contrast sensitivity, and we'll break those down a little bit. But there are other components of visual function that are difficult to simulate, and that's ocular motor control and binocular vision, color perception, light and dark sensitivity, and brain-based processing differences. Okay, so when we think of visual acuity, it's what most people think of with vision, and that's how clearly one can see. And so when you go to the eye doctor, what they're doing is they're measuring how much detail you can see at a given different distance, and then they're putting a number to it in order to measure your vision. And in low vision, doctors often will give a measurement for near, intermediate, and distance acuity. And what this looks like in practice is there's kind of different cards with letters or numbers or shapes on it, and then they go down the line and ask, read the next line, read the next line. They're looking to see, can you see the difference between the O and the Q? Can you see that little tail? Can you make out that detail to determine how clear your vision is? And so just for some images of visual acuity, near vision is about 16 inches or less. So if you think about someone with low vision, their food on their plate, when you look at this image with the simulation of 2020 versus, I think this is a 2200 simulator, on the right side, you can see some white, you can see some brown, you can see some green. If you didn't know it was a mug, you may not know what is, or if you knew it was a mug, you may not know what's necessarily inside of it. When we look at intermediate vision, so that's 16 inches to 3 feet. So in this visual simulator, it's the aisles, the rows of products at a market, and with 20/20 vision, you can maybe make out the different brands, the colors, but with 2200 vision, it's a little blurry. You can't quite make out what the products are with your intermediate visual acuity. And then, distance vision, 3 feet and beyond. So in this image, there's a woman standing with her bike. So on the 20/20 side, you can make out the bark on the trees, the brick, the grass, part of the tire. But with the 2200 simulator, you may be able to tell that it's a woman, maybe because it has longer hair, but you may not be able to see based on the face who it is. And so something important to keep in mind about visual acuity is I am a person who wears glasses, but that doesn't mean I have low vision. So the shape of your eye helps determine how clearly you can see. And so for myself, I am myopic, so I have myopia. So what this means is with my eye, the light doesn't quite make it back to my retina. So I have glasses that the lens is a shape that helps the light bend in a way so that it gets back to my retina so that I see clearly. So with hyperopia, the light actually projects behind or past the retina, and so there's a special lens, shape of a lens, that'll change the way the light bends so that it hits the retina. With astigmatism, so rather than your eye being a sphere, it may be elongated, and so what this does is it scatters light on your retina and can cause blurriness with vision. So I have astigmatism too. So my glasses take that into account with the shape of the lens in order to bend the light so that it's hitting at the right part of my retina so I see as clear as possible. And many of our students are wearing glasses, and you think, well, they're wearing glasses, so they must have 20/20 vision. But it's possible for most of our students who wear glasses, they may have glasses to correct for the shape of their eyes, and it may improve their vision some, but it may not bring their vision to 20/20. So again, I think sometimes that's an assumption people make when they see our students wearing glasses. Well, they must be able to see. Okay, so now going on to conditions, there's a lot of conditions that impact someone's visual acuity number. And again, I have these organized based on the part of the eye and the condition that's impacting that part of the eye. So we had many people up here comment, well, it was just really blurry. And if someone who had blurry simulators, how did you compensate? I see with the red shirt. So you brought what you were looking at closer to your face and that you were able to see it better, right? And that's what a lot of our students do when they're trying to see something. They walk up close to it, they bring it to their face. So that's one way of compensating. Another way that we compensate is maybe to make images or print larger for someone to be able to see details. Lighting can often impact this acuity number. So just some of the conditions we see, again, retinopathy of prematurity is going to impact clarity. Stargardt's disease is like macular degeneration. It's a condition that impacts the cones on the retina. So those are the cells that specialize in color and detail. And so they may have a loss of central vision. Raise your hand if you were wearing simulators with a big spot in the middle. I know I had a couple. One over here. Yeah, so with people with central visual loss, we'll often make things bigger so that the spot is smaller relative to the size, and we'll talk about that with visual field later. The lens, so that's that structure that helps bend light. So there's different conditions that can impact the lens. Aphakia is actually the absence of the lens. Cataracts, so babies can be born with a congenital cataract. You can also develop cataracts as you age. Many people do. And so that's a clouding of the lens and sometimes a yellowing of the lens. And so I think, Joshua, you had the blurry one. Sally, you're wearing that one. That was to simulate a cataract, so just really cloudy vision, had difficulty telling color. The iris can be impacted by several conditions. We see students with a condition called aniridia. So the iris is the color part of the eye, and aniridia will cause a gap or a spot in that iris. And so therefore the eye can't regulate how much light is getting back to the retina. And so there's a lot of light scatter, a lot of light sensitivity, and can cause blurry vision. The optic nerve can be impacted by optic nerve hypoplasia. We'll see that condition a lot. We have a lot of students with that. Optic nerve atrophy. And then, of course, the brain. So if you have a brain injury to a particular part of the brain that processes that detail vision, it can make your vision blurry, among other consequences, and then amblyopia we'll talk about a little bit down the line, but that's the brain kind of shutting off one of the image from one of the eyes. Okay, so the next component of functional vision, again, most people when they think of low vision, they think just blurry. But what I hope you'll take away today is that visual field is another important part of vision, and thinking about how low vision impacts students and how they participate at school. So your visual field is when you look straight in front of you, it's everything you can see without moving your eyes or head. So for me, if I look straight to the back of the room, and maybe I'm looking at the goal ball net, so I see one person wearing a purple shirt, I can see her clearly, and I'm aware of everything around me, but I can't see all of that in great detail, but I'm aware that it's there. So the differences between those two are your central vision. Again, that's a place on your retina that gives you the most clarity and detail, and then your peripheral vision. And that gives you a sense of, there's other visual information, picks up on movement, some shading and shadow. And there are different parts of visual field loss per eye condition. But one question I want to ask is, did you know that we all have a blind spot? Yeah? Okay, well you guys answered correctly, I guess. I have a little activity. I'm going to see how it works with a big group. So we're going to pass out cards to the people on the ends of the row, and I want you to hold onto the card first, and I'll instruct you, and then we'll get a chance to pass the card down the row for everybody to participate in this activity. Here's a card for your row. Here's a card for your row.
Anybody need the eye? Anybody want the eye? No. Might have to see.
We have a lot of people back here. So we're going to have to share because I just didn't have time to make 90 index cards this week. Okay, so you can hold on. So what I want you to do for this activity is hold the card in your right hand, and I want you to close your right eye and hold the card about like 10 inches from your face. And I want you with your left eye to look at that cross, but be aware of the dot in your peripheral vision, okay? So you're holding in front of you, and now I want you to slowly bring the card in to your face, looking at the cross, but aware of the dot. And bring it all the way to your face. Did you notice anything? Okay, so you can pass it to your neighbor, or pass it around. We'll give a few more people a try. So you hold the card with the cross on the right side of the card, close your right eye, look at the cross with your left eye, from about 10 inches, bring it in towards your face. I don't think it's... Start about 10 inches from your face and slowly bring it in, almost to your nose, and then you can pull it back out. Make sure you're focusing on the cross, but like aware of that dot. Sometimes it can take a few tries to notice what happens. Is that a cool party trick? Did it work? Hold it. I sometimes find I had to pull it back out to be aware of what happened. Does anyone want to share what happened? If you got it to work? Oh, all right. We have someone who wants to talk. All right, let's listen up. We have an observation.
As you bring the cross closer to you, it will start disappearing. You know, the black fields started getting smaller and smaller as you bring it closer to your eye.
Yes, so there. Does anyone want to add? Oh, go ahead if you can shout, or I can bring the microphone. Sometimes it depends. So everybody has a blind spot in their eye. There's an area of the retina where you don't have retinal cells because that's where all the fibers exit the eye. And it could be that yours may be a little higher or lower, or just depending on the shape of your eye and where you're holding the card, you maybe didn't quite pick up on it. Yeah, so you're fine. You have a blind spot. Oh, we have another observation.
I think the observation that I made was the feeling was startling because you see it, you know it's there, and it's like, whoa, wait a minute, it's no longer there. So you find it, you're like, whoa, it's not there.
I hear a lot of discussion. Does anyone have anything else to add? So one thing I want to ask, for those who the dot disappeared, was there a big black spot in your vision when the dot disappeared? It was just gone. And so it just looked like an index card with a cross on it, right? So the interesting thing about visual field, and if there's a condition that causes a blind spot, like a larger blind spot in your vision, or the loss of visual field, is oftentimes the brain fills it in. And so this is really important to think about with students who have a loss of visual field, is depending where an object is in space, depending how close they are to it, that object could be right in their blind spot in a given moment. And then, they move their hand, they couldn't visually sense something was there, they bump into it, or if there's something on the ground. Again, they're not seeing, there's not like a curtain, there's not a red alert that says, you can't see in that area. Oftentimes, the brain is an incredible machine, and it fills in the image. And so, to talk about different types of visual field loss, first we'll talk about that central field. So there's several common conditions that cause loss of central field. And let me find my notes so I don't get anything. So for a condition that causes difficulty with the central field, again, it may not be a spot, it may be blurry. As one of our staff said, it could be more like kind of wavy lines, like distorted a little bit. It just depends on the disease process. And common conditions are a scotoma, so this is just a little spot in the central field that could be caused by a retinal condition, surgery, a scar, diabetic retinopathy, Stargardt's disease, macular degeneration. These are all diseases of the retina. The optic nerve, if there's atrophy or damage, could impact the central field. Leber's hereditary optic neuropathy is another condition that's acute onset of loss of the central visual field. And so the two images on this slide, the first shows someone's looking ahead, they're able to sense where they are in space. I'm walking down this cute stone pathway, there's flowers hanging from the windows, but I may not be able to tell if this person in front of me A, who are they? B, are they walking towards me? I can't tell, is that the front of the face, the back of their head? And then the other image is of print, and it's showing that when there are spots in that central field, and when your two eyes are looking at text, that little spot in your vision makes it so that you're not getting all the details of the shape of a letter. And so with kiddos who may have central field loss, it may seem like, oh, they're flipping their, D and B, or an S and a 5, and that could be because something is blocking that sensory information about the visual form. And as I mentioned earlier with like macular degeneration, Stargardt disease, one strategy is using a magnifier, enlarging prints and images, and that's in order to make the little blind spot relatively smaller to the image to take in more details. A lot of kiddos and adults develop a different way of looking so that they're using a different part of their retina that's the next best place to see, because this field loss is in the part of the retina that specializes in seeing color and detail. And so they may learn, like, if I look a little to the side, I'm going to use a different part of the retina to see this face or see this print. And some people are really good at it. Sometimes it depends on the size of the central field loss. So you may have students who, when they're talking to you, they're looking a little to the side or they're turning their eyes. And that's okay. They are compensating. And that may also be, when they're reading or looking at something, they may look to the side or turn their head. And in education, a lot of times we talk about social skills and we ask students, like, when you're talking to me, you need to give eye contact. Well, for some students, giving eye contact may not be how you and I give eye contact. It may look a little different so that they can better take in your facial expression. Or, maybe if they're a student with hearing loss, to read your lips. So it looks different for kind of each student who's compensating for this type of visual field loss. So the next category of field loss we'll talk about is peripheral field loss. And so conditions of the retina that cause peripheral field loss, so that's the visual information from around the central vision, so from the bottom, the top, and the sides. Retinitis pigmentosa is a genetic condition that causes the specialty rod cells that detect light, low light. They essentially die over time. Retinopathy of prematurity can cause peripheral field loss. Optic nerve damage, including from glaucoma, atrophy, or damage. And then brain injury that impacts a certain area of the brain could also cause peripheral field loss. And one important distinction, and this is one of your quiz questions, is for someone with peripheral field loss, if you only are looking through a small window, would it be helpful for you to make everything bigger for that person? No. And why is that?
Because then you're like, if you only have this little space and you made it this big, now
You got to do a lot of searching. Yeah. And so that's one misconception, like in the low vision field. It's like, well, you just make everything bigger. Then they'll be able to see it. But for someone, if they just have peripheral field loss and their acuity is still really good, they don't have anything else going on, you wouldn't necessarily want to make things bigger. And another thing to keep in mind for people with peripheral field loss, mobility, that's a very important implication of this type of field loss, because if you're not getting that sensory information about your surroundings, you may not see that there's a chair in the way, that someone's backpack is on the floor. And so working with the orientation mobility specialist for that child to develop cane skills so that they can detect if there are things in the environment that those light sensing cells aren't picking up on and telling them about. Okay. So there's also some other patterns of visual field loss. The ones that I'll bring most attention to is diabetic retinopathy can cause damage all over the retina, so there could be spots in all parts of the vision, central and peripheral. And then on the right side of the slide, it shows the top image, you can only see half of the visual world. The bottom image, you can only see the left half comparing the full image and then the one next to it. And that's called a hemianopsia, and it's a very particular type of injury that causes you to only be able to see one half of the entire visual field. So if I'm standing here and looking straight ahead, I would be able to, sense everything visually from Cynthia on back, but without moving my eyes or head, I would not necessarily have information about what's to the right of that. But again, it depends kind of where in the brain that'll cause it to be either the left or right side. And again, lots of implications for mobility, being able to detect obstacles, lots of implications for reading. If you think about if I can't detect the visual information to the right of my visual field, well, what direction do your eyes move when you read? They're moving to the right. And so it just makes it a little more challenging. Okay. The next component of visual function that we were able to simulate was difficulty with contrast sensitivity. So most, if not all, low vision conditions have some implication for contrast sensitivity, and that's one's ability to detect an object or image from its background, your ability to be able to see differences in shading and patterns. So if you think about yellow and orange, like those two kind of sit next together on the color spectrum. Someone with a loss of contrast sensitivity may be difficult depending on certain shades. Is that an orange shirt or is that a red shirt? And so this has really, really great functional implications for our students or for adults with vision loss. And so the images on this slide, one shows a chart that doctors use to help measure someone's loss of contrast. And then the picture in the center shows there's an image of a street with a building, street signs, trees, cars, and then when you put, I think that's a cataract simulator over top, so clouding of the lens, you lose some of that detail and some of that contrast. And then on the right, there's a picture of a white dish with white eggs in it, hard-boiled eggs. And again, without that contrast detection, if someone with vision loss, they may not see that there's anything in that plate or bowl. Here's some more images. So loss of contrast sensitivity is really important for mobility. Again, looking at the left side, you're able to detect because of the shading, like, oh, those are stairs going down. But on the right side, I may think that's a ramp. And I may just put myself forward and not know to take a step. That went too fast. And then again, we were able to simulate in our activity today that facial features are extremely low contrast. And so our kiddos, depending on the level of vision loss, it may be really difficult to detect. Is someone smiling? Are they neutral? Are they frowning? And so there's a lot of implications for social skills, and that's why we have to directly teach how to detect different emotions and social interactions. And I do want to also bring to attention our school. We're a school for the blind, and so I think they really try to do their best with redesigning buildings in order to enhance contrast and to give kids with a loss of contrast a better sense of space. Like on the stairs, there's markers on the edge that are a bright color compared with the rest of the step to cue them visually, like, oh, there's another step there. So now as you go out into the world, not quite yet, I want you to take a look around and see if you notice, like, oh, they really tried to make a feature stand out. I bet that's to help with someone with contrast sensitivity loss. Okay, so now briefly we'll go into visual functions that are difficult to simulate. And the very first kind of idea I want you to consider is binocular vision. So with typically developing vision, you have two eyes, and because each eye is on a little different position on your head, you're actually getting two different images to your brain. but then your brain makes sense of it and puts it together in one image. And that's what gives us an idea of width, depth, height. Very important when we think about mobility, participation in activity. So if a student has maybe one eye that's more impacted than the other, there's a really good chance that they have a loss of binocular vision and they may not quite see shapes quite in 3D. And a brief story is one of our staff members here, due to her low vision condition, she does not have binocular vision. She has a lack of depth perception. And she warned me one time we were driving somewhere. I was driving. And she was my passenger in the front seat. And the first time she was my passenger, she said, you know, when we get on the freeway, there's a good chance I'm going to scream. And I was like, okay. But like, sure enough, we're on the freeway. And particularly when I'm a slow driver, tell Barb, I drive in the right lane. If traffic was merging, to her, because she couldn't judge the distance between two cars, if you see there's a car in front of us, there's a car merging, and you don't have those visual cues of like one's in front of the other, what does it look like they're gonna do? They're gonna crash, yeah. So important to keep in mind that, you know, low vision, it could be that someone has a lack of being able to judge depth and width. Go ahead.
So what actually causes the depth perception?
We'll go over some conditions, but really any of these, especially with kids, because they, from birth, didn't necessarily get that clear message to the brain of the image from two eyes. It's really, depth perception can be a really big issue, and you know, a lot of our kids, they compensate really well, or they may have learned cane skills, and so, you know, they move quite fine, or they have good reactions and balance, and so it may not be obvious. But next, we'll briefly talk about like one primary cause of loss of depth perception is if there are issues with ocular motor control. And all this fancy word means is your eye movements. And our visual system is designed to try and keep the visual image stable and centered on that clearest part of our retina. We have 6 eye muscles. They work together in order to move what you're looking at from one place to another, in order to follow something that's moving, in order to bring something close to your face and for it to stay in focus. Many of our students have conditions that impact the eye movements and it impacts what they see. Probably most commonly is strabismus. So this top image, there's a kiddo who one eye is looking forward and the other eye is turned in. And so with this condition, the brain is getting 2 different images. And what often happens with kiddos with strabismus is the brain may turn one of the eyes off. It may be like, this is confusing. I'm going to rely on the vision in your left eye to tell me what it's looking at. And that condition is called amblyopia. And so one eye essentially becomes weaker. And with young kids, that's where you see doctors using like eye patching or these special type of eye drops to try and strengthen the eye that the brain's trying to turn off. There's also some surgeries to correct it, but it doesn't always fully correct it. But so that could be a condition that causes issues with depth perception. Congenital nystagmus, so this is a condition where the eyes have what looks like uncontrolled movement, so you'll see like a rhythmic back and forth. Sometimes the nystagmus is in a different direction. Sometimes you'll see kiddos kind of turn their head to one area to look because that's where the movement of eyes actually slows down. That's called their null point. And so nystagmus results usually in blurry vision. Optic nerve hypoplasia and atrophy can cause, again, a nystagmus type of lack of ocular motor control. And then a brain injury could cause like a palsy to the eye muscles, much like, you know, someone with a stroke, they may have weakness on the right side of their body. Well, that can also happen with the eyes. And so these other images show how someone who is having difficulty with coordinating those eye movements, they may have a little double vision depending on the position of the eyes. They may have the lack of depth perception, so rather than seeing things in 3D, it may look a little more 2D, for lack of a better word. And other functional implications for ocular motor control, like we work at a school, so if you can't fully control how your eyes are moving, reading across lines of text can be challenging. You know, it may be harder to move from one word to the next. It may be difficult to move from the end of what you're reading on the right side of the page on one line and pull your eyes back and find the beginning of the line on the left side of the page. So there's, you know, lots of functional implications, but there's also ways that kiddos compensate for it. Okay. And then another category of functional vision that's a little difficult to simulate are differences in color perception. Again, you'll see some of the same conditions: macular degeneration, diabetic retinopathy, achromatopsia is a really rare condition where there's a lack of color vision. Some people with achromatopsia see in shades of gray, white, black. Cataracts, some cataracts have a yellowing to them, so that can change color perception. So color perception is more than just color blindness. And then glaucoma, optic atrophy, those are all conditions of the optic nerve that may change, again, that information going to the brain about color. Okay, before we get into, and we're almost done, don't worry. Our next category, so what are some examples of lighting sources in our educational environment at MSB? You can just call them out.
Overhead lighting, natural lighting, task lighting.
Wait, she knows. Did you say task lighting?
Task lighting.
Task lighting. Does anyone else want to contribute? What does everyone have in their pocket?
Screens.
Yes, screens, thank you. Miss Lenny. So in our classrooms, there can be natural lighting, overhead lighting. A student may need a lamp on their desk to add additional lighting, because that can help with contrast. There also may be reflective lighting off of surfaces. So whether it's lighting hitting the desk and bouncing back to people, or a lot of technology, you know, that really clear screen we like to have actually has a lot of reflective light back at us. So there's many conditions that impact the eyes and the brain's ability to adapt to light and dark conditions, and sensitivity to bright light, or ability to detect light in low lighting situations. And so there's kind of conditions, and I don't have these fully broken out, but there are kind of the two extremes. So if someone is super sensitive to light, a snowy day may be very difficult to tolerate. In fact, someone may feel blinded on a day where it's snowing and there's a lot of reflective light off that snow. Conditions like albinism and aniridia, again, make it really hard to tolerate levels of lighting. Cataracts, because of that clouding, can really cause the light to diffuse and like scatter. Brain injury can cause sensitivity to lighting. Nystagmus with the eye movements can cause sensitivity to lighting. And then on the other end of the spectrum, retinitis pigmentosa, so that's that tunnel vision. Because there's a loss of those rod cells that detect light in low lighting conditions, it means in classrooms, outside at dawn or dusk, that person may feel blinded in those lighting conditions because those cells aren't able to pick up on the light. So I think that's a few more pictures. So the next image shows on the left the lighting conditions that someone with retinitis pigmentosa or glaucoma, also tunnel vision condition, what they may see in a low lighting condition. Let's see if I can make, and so this is, again, if someone's super light sensitive, glare, coming maybe over the top of someone's glasses, they're not wearing a hat, it can be very blinding. I want to show that last picture. Okay, and then lastly on this slide, I'm showing an image and there's really big shadows across the sidewalk. So someone who maybe has difficulty detecting light, what could those shadows be mistaken for? Yeah. So it could be
For a drop off?
yeah, it could be someone they may be perceiving like, is that a drop off right there? Is that a step? Is that a physical form like a column? So again, it can be perceptually confusing if someone has difficulty in different lighting conditions, and that's where that white cane training is so important, so that they can confirm through another sensory channel, am I seeing what I'm seeing, or is it something else? What we are not going to get too into today is CVI. So this is one of the most prevalent conditions on our campus, and it's a brain-based visual impairment, considered a form of low vision, where everything with the eyes checks out, but the child is not quite able to use their vision in the way a child of a similar age may be able to use their vision. So I'm going to see if this controller lets me play this video. No. All right, I'm going to click on it. But this is a video from Perkins that's really brief about what CVI may look like to a child.
What is it like to have CVI? For a child with CVI, the world can be an overwhelming, exhausting place. What they see is a swirling mass of color, motion, and light. Other people with CVI tell us they see
Sorry, I can't get this out.
but struggle to recognize even their own parents. CVI, or cortical cerebral vision impairment, is the leading cause of blindness in children. It affects an estimated 150,000 children in the United States alone. Every person with CVI experiences things differently. But what matters is we can help kids with CVI make sense of their world as long as we help them grow. So join us. The time to help kids with CVI is now.
Alright, so that's a brief video showing what it may look like to a kid with CVI. And I think of this as a spectrum condition. So there's different kind of severity. Like I mentioned, there could be a difference in the brain that causes no perception of light or objects or image to, maybe the world looks moving depending on where that information, the visual information is going. Or, a kiddo could be pretty high functioning, but maybe needs some supports to help make sense and for clarity of what they see. Some common causes for differences in the brain for a condition like CVI include premature birth. So again, the brain isn't fully developed, hasn't had the time to kind of make all those connections in the brain structures. Early brain injuries such as trauma or infection or hemorrhage, like a stroke, cardiac arrest causing lack of oxygen to the brain can cause an injury to the brain, and also genetic conditions could impact the development of the structures that help make sense and perceive visual information. And then some common features. Someday, a kid with CVI. That one's a little longer.
I am Savannah's mom. I had no idea.
Okay, so some features that you may notice about a kid with CVI is they may have a color preference in order for them to engage with looking. You may present something visual, it may take them a while to look at and engage visually. They may not kind of seem to pay attention to different areas of that visual field. They may have difficulty with new items. They may have a preference for looking at lights. They may have other unusual visual behaviors. They may have better vision when something's moving than if it's stationary. And they may have difficulty if the visual image is complex, if there's a lot of clutter. So these are things to keep in mind if you're working with a kiddo who you've been told, well, that person has TBI. And again, we have 2 experts coming in a couple months that study brain-based differences in the use of vision. I'm really excited to hear from them to see what sort of updates they have in terms of how can we understand what a kid sees and how can we help support for them to help develop the visual brain or to function with, you know, how the brain does use vision. So where can I find information on the student's low vision condition? An ophthalmological report will give you the diagnosis. So an ophthalmologist is a medical doctor, and they focus on diagnosis. The functional vision assessment is an educational assessment done by a teacher of the visually impaired to describe how a student is visually functioning in their academic environment, in their classroom, in the school. And the kiddo may have gone to a low vision clinic and had a low vision evaluation with a special type of optometrist who may spend more time looking at how can I prescribe glasses or any other sort of magnifying device in order for that person to use their vision as best as possible. So, what can we remember? The visual system includes the eye, the optic nerve, and it's the brain that sees, that makes sense of that light information. Vision's a continuum. It's not just blind and totally sighted. There are different components to vision that a condition can impact what is seen. So it's not just blurriness. There's acuity, there's visual field, how much one can see at one time. There's contrast sensitivity. Does what you see stand out from the background? And simulation can give you an idea about what it's like to have a visual condition, but it doesn't give the full experience of living with low vision or blindness. Any questions? It's Friday. Sarah, do you have anything? What's that?
I just need to talk about the post-test.
Oh, you can talk about the post. So no questions, you can always email me, Amanda A. Was this too much? No. Okay.